Hello, everyone. Welcome to our fourth Reactive online meetup. First of all, let me tell you that I really hope that you are all staying home safe with your families and you are not stressed out about the COVID situation and you are enjoying some great books or games or online presentations. I'm really excited that you made the decision to stay ahead of the curve and spend this evening with us. It's really great to see so many attendees. To introduce myself, I'm Andrej Skok. I will be host today, and I will be also the meta speaker. I work for Vacuum Labs, which is the company that stays behind and was behind the original idea of the ReactiveConf back in 2015. We are focused on providing the flexible and reliable software engineers to clients all over the world, from Los Angeles to Tokyo, basically focused mainly on fintech and blockchain projects. My position in the company is that for 4 years already, I am a front-end tech lead working for Kiwi.com, the airplane tickets selling company. Before my presentation begins, let me just give you a few notes how this will be organized. So first of all, there is a Q&A. There is an option to ask questions on the bottom of your Slack windows. Feel free to ask questions anytime during the talk. After meta talk and even after the main talk, there will be 2 separate QA sessions, and hopefully all your questions will be answered. Secondly, there is a Slack channel, reactiveonlinemeetup.slack.com. Feel free to join and ask questions and discuss topics even after the talk. So we'll be really glad if you will join. SWIZEC and also me, we are both there. Also, there is a main speaker available on the call. So welcome, SWIZEC. How are you doing?
Hey, I'm doing pretty good. How are you?
Yeah, also great. I'm really excited for the talks. Of course, for your more than for mine, but it may not be the same for all of the attendees, hopefully. So pretty much what is left to say is that stage is mine, and I will just start with my presentation. So enjoy your evening, grab your beers, and let's start. Hopefully you can see my screen. Perfect. So I choose the title for my meta talk to be Mind the Perf. And I hope that you will mind the performance a little bit more after this meta talk. First of all, who is behind the screen? So I have already introduced myself. For 4 years, I'm working on a web in the travel industry. I've been part of Vacuum Labs for 5 years, so that's my coding career. My handle on the most popular ornithologist website is at Andrej Skok&Swizec. So you can get in touch with me there. I retweet a lot of tech. So to give you a context and some initial setting, so how we were thinking about the performance when we started, and I will try to just show you the steps that we have taken just to reach our goal. So when we first started the code base, when we started thinking about performance, the performance is our problem. The code base was 5 to 6 years old. The problem was that the tech changed multiple times and matured in the times of JavaScript fatigue. So there was a really great idea every day what we should do differently, and we never stick to one proper technology for a longer period of time. The code base was growing. Pretty much features were more important than performance, and we were adding new features, new A/B tests. So we were going through a lot of redesigns after some UX research was done. The app felt slow. We made some measurements and find out that we are really lagging behind the industry standard in terms of basic performance, like time to interactive, visually complete, or page load time. For us, the initial load stopped at around 1 megabyte of JavaScript and 5 megabyte of total assets after the compression. It may not sound like much, but industry standard was maybe half of that. Today, my main goal is to summarize the steps which we gradually took and which pushed us to much better performance, and in the end improved our code base quality and also the processes. The prerequisite of the tech you should know is pretty much the Webpack, Babel, and the basics of JS ecosystem. It will be really high level, and it will be more about concepts than some really specific configurations. My first recommendation is that mind the dependencies and mind them from the start. It may sound really trivial, but at first, our dependencies or third-party libraries in our code made up more than 60% of the code base. There is nothing inherently wrong with using the dependencies and using third-party code and using it wisely, because pretty much that's what we all do. Like, we reuse someone else's code because we do not want all to build everything from ground up on a green field. But make sure that you are using your dependencies wisely and to the fullest, and you are not including tens of kilobytes of code and using just a few functions from it. That really make no sense, and further analysis could have been done. What is more important, that it's not just the library itself, but the dependencies that come with that library. What were our steps were that we started to actively search for libraries that do exactly the thing that we need it to do, and the library itself has minimum dependencies. That's pretty much like using Lambda over Lodash. Lambda has no dependencies, I think. Date functions over moment, or throwing away the libraries which you probably do not need, maybe immutable.js. Like, we know that we cannot get rid of it completely because it's dependency to many other libraries, but at least we can try. And do not have it there in our bundle multiple times, for example. This has other great consequences, like having faster pipeline, install time of the application, the faster security audit, run on NPM. I recommend using some of the web pages which will tell you more about the libraries that you are using or going to install, like bundlephobia.com, which has a pretty great overview that what's the size of the library, what are its dependencies, how big they are, how the size of the library is changing with the versions. So that's a really nice to do at least a basic check of some dependency that you are going to add to your code. Also, we started to periodically check whether the dependencies still make sense. So maybe there is some better alternative which may not have existed before when we started the programming, or maybe there are some dependencies which can be dropped altogether, which may always happen in a pretty big code base, that the cleanup is not always on 100%. My second recommendation is that if you have to use the dependencies, to reshake them. So if you do not feel like removing the library, that's still fine. Maybe there is nothing better which can be used at the time, but you can always save a few kilobytes if you reshake it properly. it may be the case that you are just importing the entities in the wrong way, and you should just install some Babel plugin or Webpack plugin, which will just, during the transpilation of the code, adjust the imports so they are used properly and in such a way that they can be tree shaken. In my own experience, some Webpack plugins are a little bit dangerous, for example, for Lodash, because they alter the behavior of the library. They try to optimize so much that they will even remove something that was really important. So be aware, but at least give it a try. Our next step was to analyze our bundle size, and our analyze it regularly. So we started to use Webpack Analyzer to do at least the basic bundle structure overview. So this is pretty much how it looks like today. It gives you a pretty great overview that what are the big chunks in your code, like what is the latest JSON? Can I remove it? Do we need it? Why is this having 100 kilobytes? Can I remove it? Can I split maybe some chunks even more? Who knows? Is it worth it? So you can start asking a lot of useful questions based on what you can see. So the tooling was essential, and then we start asking questions. And at first, pretty much, basically, we had one bundle, and everything was in one chunk. It was quite easy to spot some low-hanging fruit, big chunks of code which are loaded at the wrong time or do not need to be loaded at all. It was just dead code, and there was so much of it that it was pretty much obvious that it has to go away. And our main goal was to start using dynamic imports where we could, and minimizing the visibility of loading on the page due to code not being ready yet. So we started offloading the features in models, the features which are not so heavily used based on our analytics, or for example, language mutations for date functions or moment libraries. That there are pretty huge chunks of code, and they are probably not needed because you need just that one language which the user is currently using and see. Quite naturally, we came to a point where we started to use dynamic imports per screen. I will call it a scene, and created one chunk for common code, of course, but the result was not as we expected. We ended up pretty much with each scene having 1 to 5% of the total size of the code, and one big common chunk having the rest 75% of the size of the code base. So that was pretty much not ideal. We were hoping for something more even. So this is something which helped a bit in terms of performance of loading of our page, but it was far from optimal. So we decided to split the monolith. And the main problem was that, which we realized pretty quickly, that there are some big nodes in our dependency graph, which were pretty much the files which included a lot of other files and were gluing the code base together. So a nice example, if you are using Redux, is your reducer, in which you are combining all of the other reducers. So this is pretty much where you are importing all of the other reducers. Those are importing the actions. Those are importing maybe some types, some utils, and whatever. So these were really the glue of the code base. And the second problem was that we were cross-importing too much. Like there were the files from common were importing from other scenes. The scenes were importing one from another instead of putting the code in common. So it was quite a mess, but it was not visible at the first sight. So we started to clean up the mess, and we started with ESLint rules, because ESLint for the win. When you need to enforce something which can be done by static analysis, just try to write a static ESLint rule for it, because there is no chance that if you write it in some code review guideline that people will not overlook it, will stick to it. You have to really enforce it properly. So we started to write a lot of ESLint rules for restricted paths, what can be imported from where, and start cleaning up the code and pretty much breaking up all the nodes which were gluing the code base together, but they didn't have to. It was just our fault. We took also an extra step for landing page, because the landing page loading time was the most important for us. What we really wanted to achieve was that for a landing page, we would load just the code which is needed to be run on the landing page. So we will not waste time parsing and executing the common code, which ended up in a common chunk and loaded on the landing page, but was not actually used there. So we ended up with two common chunks. The first one was the common part of the code, but was landing on the landing page, and it includes just the common code shared by the landing page and the other modules. And the second chunk was the common code loaded shared just between the rest of the other chunks. So on landing page, we loaded just the first one, and on all of the other pages, we loaded both ones. This was a great saving for us. It saved us like 20% of the code size. So we were on a really good track here. The second optimization we made here was that we separated the so-called stable libraries and the dependencies, which we do not update very often, like React, maybe styled components, which are not like crazy updated but only on just some regular basis, so that we can cache it for regular users. This also helped much for subsequent visits. Even some more optimizations with it, and to summarize it on one slide, pretty much we prepared two different bundles, modern one and the legacy one, and we served them based on the browser. So there is a great advantage when you do not have to transpile the code to some legacy constructs and use directly what browser is allowing you to use. It results in a lot less lines of code. Pretty much we could drop a majority of the polyfills for newer browsers, and we saved around 10 to 15% just on the transpilation itself. I also strongly advise to start pre-connecting to domains which have and provide blocking resources. I even suggest to shave off some time by declaring in your head of the document the scripts which need to be preloaded. So it will not block the parsing, but the browser will start fetching those resources. And also optionally, as I said, we wanted to minimize the loading, which is shown to user because the code is not loaded yet. So we started to pretty heavily use also prefetching, but only in times, of course, when the user will choose that now is the right time to prefetch the code, and not forcing it to fetch it at times when it has a lot of work to do to load the page. We lazy loaded other assets which we could, all off-screen content, all the images, all the non-critical CSS. So this saved us another milliseconds, tens of milliseconds, and a lot of bandwidth during the first load. Just to keep the bar high, do not rely on the code reviews only. you have to just enforce it by rules against bad practices and bad habits. Pretty much that's what linters are for, and I would suggest to use them whenever possible. You need to do at least some basic sanity checks in CI. For example, check for your size limits, set some proper size limits for your chunk, and keep tracking them, and let your pipeline warn you or fail. And then, of course, production perf monitoring. On server side, the response time, 95th percentile response time, request taking more than X milliseconds, whatever may feel slow for a user. And on the client side, tools like pingdom, speed curve, and checking there for a total bundle size, time to interactive, time to first byte, and some others if you find them interesting. And to just wrap it up, our final results were that after 1 year of gradual refactors while adding new features, so no situations like we have to stop adding features for a week because I have to do one proper refactor, nothing like that. Our HTML size dropped from 200 to 25 kilobytes. We got rid of 100 kilobytes of CSS. By using styled components and having critical CSS in the HTML, and our JavaScript size decreased, not increased, so that's also pretty important. And we managed to reduce the time to interactive by 30%, the page load time by 20%, time to visually complete by 50, 40% was the saving of the JavaScript altogether. And we shaved off nearly 60% of the total size of the page. So currently something about around 2 megabytes, not 5 like it used to be. Of course, like with everything, there is one catch, and that is that you need a really awesome team full of great developers to achieve something like that, and a constant support. So really big thanks to them. But it was a great experience that 1 year. Yep, and pretty much that's it. That's everything from me. I will now just stop sharing and we can move to Q&A. So let's see. No questions there.
I actually have a question.
Oh, let's go for it.
So you mentioned that limiting dependencies was something that really helped you with your bundle sizes and how much JavaScript you load. How do you feel about copy-paste dependencies, where you find a project on GitHub that does what you need and you just copy-paste its code into your repository?
That's a really great question. Like I don't think that this is something you want to do or on a regular basis or with the majority of your dependencies, because then you have to support them all pretty much. But I did it. I did a few things. Sometimes when the dependency is really old, I just copied it over and just rewrite it maybe to something more modern, and maybe just got rid of the unnecessary parts. So yep, I think that's doable, and it can be done. The second one was that I was forking, and I'm still actively forking the repositories and making them more modern. So I will get rid of, for example, the dependencies which have known critical security issues with them. And this may be the case, for example, when the library is not maintained for a year, it almost certainly appear that this kind of issues. So I'm doing these two approaches, and I feel until now I feel fine with it, but I wouldn't want to do it with many libraries, to be honest.
Yeah, totally. I got the idea from ACD Light on Twitter, because he said that when he finds a small package, it's easier to just copy paste the code rather than add another npm dependency.
Yep. Even more when the code is using really dependencies which are not really necessary or you do not feel comfortable with them. So yeah. Great. Awesome. If any of you have any questions or I was too fast, just write the questions down or just get in touch with me on the Reactive Online Meetups Slack. So feel free, everyone. Okay, SWIZEC, pretty much the stage is yours. So prepare your screen, and we are really all excited and looking forward. So let's bring it on for a guy who is using Redux for the half of his career. So let's do this.
All right, let's share screen. Okay, so hi everyone, I'm Swizz or SWIZEC, depending on how Americanized you want to pronounce my name. And today I'm going to talk to you about a pattern, not a library. A pattern I'm calling the wormhole state management pattern that I kind of developed when I was working on a library that some people are using. And I discovered this really cool pattern that lets you manage state in a more manageable way without using any dependencies, without state management libraries, just using stuff that's already in React. So, oh, by the way, I don't have an intro slide because I don't like those. If you want to know more about me or if you want to reach out, I think if you type SWIZEC into Google, you're going to find a lot of stuff about me. So I don't know how long you've all been React developers, but you might remember back when React first came on the scene, it made a huge splash with this unidirectional state management system or unidirectional data flow. Because back then, this was what, 2014, 2015. I don't have a mouse when I'm presenting. That's fun. Cool. So I can't open the chat room. So back in 2015, 2016, somewhere thereabouts, the way we used to build these web apps was that you had a lot of painful pain with doing state management. You could either use an event-based system like Backbone, which very quickly grew to a point where you just had no idea what's going on. You clicked a button and a bunch of events fired, and you really couldn't tell what was going to happen when you did anything on the page. Or there was still a lot of jQuery stuff, things like that, where every state update caused a bunch of re-renders and a bunch of DOM reflows, and it was just terrible. So then, oh, and the other popular one was Angular with bidirectional data flows, where you had bidirectional binding and you could change the state of some variable and it would magically update everything that depended on that variable, which sounds really cool when you're building small demos, but then it very quickly becomes very painful and gets out of hand, and you just, oh, am I actually, oh, I'm not muted. It basically becomes pretty problematic very quickly. I don't know if you've worked with code bases like that, but it doesn't feel nice when you change something and you don't know exactly what's going to happen, or you have to trace too much of the code to figure out how things are actually working. So the unidirectional data flow was this wonderful idea from the Facebook team, from Facebook's React team, where you could suddenly understand how your entire application worked. Data would always go just in one direction from the top, from your top component all the way down through your component tree to the bottom where something changed. So you always knew exactly what was happening. The idea was that your UI would be a direct representation of state. You would always know, okay, this is, if I change state, I know that everything updates and I don't have weird additional things on top of my state updates. Actually, the chat room notification is really bugging me, so I have to click that. So maybe I can see the chat while I'm doing. No, it just shows, oh, there you go. Okay. So, okay, so now I can see the chat. I don't know if you can see the chat while I'm sharing the screen, but whatever. So basically, the idea of the unidirectional data flow was that it makes your application more understandable. Your data is going only in one direction. You always know what's happening. UI is a pure representation of state. Because you have all of your state stored in a single source of truth, it's very easy to sync between different components, so you can know what's going on. You can say, okay, I'm rendering something all the way here on the left, and it depends on something a component over here on the right does, and you connect them together over the single source of truth, and everything is updating and super awesome. So that was nice. But I think we kind of, started taking it way too far. Everybody who was teaching React back then, and I think it still happens a lot, was saying you should put everything in your top component. Top component should hold your state, and it should hold the state for your entire application. And then you had to deal with prop drilling. You had to pass everything down. Then you had to pass callbacks back up the state tree. So the prop drilling was a huge problem. You ended up with extremely tight coupling between components. So if you wanted to move a component from the bottom of your DOM tree or of your React tree to a different part, you suddenly had to change every component that was on that path. So everything that was between the component you were actually changing and the component that was, so everything that was between the component that held state and the component you were actually changing, you had to change all of that if you wanted to move your component somewhere else. So that was a huge pain in the ass. So people, very smart people, were like, you know what, we can solve this with state libraries. So then we had this proliferation of state libraries. We had Redux, we had Mobex. I think we had a couple of others, Redux and Mobex, I think, are still the main ones that people use. And they're great. They're awesome libraries, amazing to use when you're starting out. Well, maybe they're not amazing to use when you're first starting out because it makes your application really complicated. It makes it very hard to know. Well, it makes it relatively easy to know what's going on, but the complexity of your application basically just explodes. Suddenly you need to change 5 files if you want to change how something works. You need to add reducers, you need to add actions. Then people are saying you should have all of your actions in one file, but then your files become too big and you start changing things into sagas or chunks or whatever other things there are. And basically, your code base becomes really difficult to understand. Whenever you change something, you suddenly don't know everything it's connected to, which is fine in a way because potentially if the abstractions are well done, you don't want to know everything that's connected to your component, right? Or connected to your state. You also get this really nice separation where you have a state layer that lives outside of your component tree, so it becomes easy to move components around. You just hook them up to your Redux state or to your Mobex state, and it kind of just works, right? It's a pain in the ass to set up. You have to deal with a lot of boilerplate code to get everything working and set up and running. When a new junior joins your team, they probably really struggle with how to make anything work here because there's just a lot to understand. You have a lot of complexity. And what I think is the biggest problem of these libraries is that they break the collocation principle. So suddenly what you're doing and what you're displaying, or your UI and your business logic or user interactions and all of that, are just not close together anymore. You have to keep a lot of context in mind to be able to make any change. You have to, I don't know how often you've approached a Redux or Mobex codebase that somebody else built, you weren't the one building it. But if you don't understand the entire system, it becomes almost impossible to understand how anything works. I remember walking into a Saga-based project once, and it took me 3 or 4 days just to barely understand how it works, because you could click something and a bunch of things happened, and then a bunch of other things changed, and I had a lot of unknown side effects where things were re-rendering and changing that I didn't even know existed. Or I wanted to just change how a button works, and I changed that. I made the small change in the button, and suddenly my header started changing, and I was like, what? No, I don't want my header to change in all cases. Maybe I just want to change it in some cases. So all of that becomes really difficult and means that you have to be able to basically hold your entire code base in your mind, which is great as long as it's a small code base. If you use this principle of splitting up your monolith, it's great because you can have small, simple apps, each deployed in a separate Jamstack or wherever you deploy them. So that kind of helps with that complexity, but eventually your complexity is going to grow. I know we tried to work with micro frontends, and that never really went anywhere and was a huge failure. So what I want to propose today is a new way of managing your state that mostly solves all of these problems and makes your life a lot better. And I'm calling it the wormhole state management, because it's based on the idea that you have a lot of local state localized to the smallest possible part of your state tree, and then you have wormholes to make different parts of your state communicate with each other. So the principle is that when you have state that belongs just to a single component, where just a single component cares about that, you can just use local state. With React hooks now, it's super easy to use local state without too much trouble. You don't have to deal with the set state. Well, you still have a set state function, but you don't have to build a class-based component just to have state. You can use functional components, which are, in my opinion, nicer to work with. And you can use state locally, and it's self-contained within the component. Anyone who looks at that component can always know everything that that component does, all of the business logic it's using. You can then, if you have different components that work tightly together, that are really actually tightly coupled, like we'll do some examples later, but let's say you have a button and a display component next to it that shows how many times that button has been clicked. You can just share state between those two components. You don't have to go all the way around to your global state just to change something that's right next to you. Imagine if every time you wanted to ask your coworker to help you out with something, you would have to write a formal request for help. Then you would have to pass it on to your manager. Then your manager would pass it on to his manager. Then his manager would pass it on to her manager. And then the CEO would look at that request for help, and she would be like, yes, it does sound like SWIZEC needs Andrej's help. Okay, this is good. And then she would put that into HR, and then HR would look at it eventually, and maybe 5 days later it would come back to Andy, who's sitting right next to you, and he would say, yeah, totally, you can just click that button over there, or just copy paste that thing and it's going to be fine. So that's kind of how we work with Redux and Mobex, isn't it? You go all the way around to do the simplest possible things. So with the wormhole pattern, you get the collocation of logic. So anyone who looks at a component can always understand that component. As a result, you also minimize the amount of code that needs to be understood, because you'll see with some React hooks, you can then make it very easy to share state between components without introducing a lot of extra code. You're not using any libraries, which is great for performance, because it means you're not downloading extra libraries, you're not compiling extra libraries, you're just using every stuff that comes with React already. And at least in my experience, this same approach scales pretty well from very small apps that you're building as just a tiny example to huge apps that have a lot of different layers or a lot of different segments of the app that need to work together. So rather than talk your ear off about the theory, I figured I would just show you how this works if we go to this code sandbox over here. So you should still see my screen. And I'm gonna show you how the wormhole state management pattern evolves from the smallest example to something that is more like a bigger app using code and a bit of live coding. I haven't prepared a whole lot in advance because you don't need a whole lot in advance. That's kind of the point of this pattern, is that it's simple and easy to understand. You will, however, need to be relatively familiar with hooks, because if you're not, then it doesn't work. So let's say we have this code sandbox over here, and we want to make this +1 button that is a simple counter. I know that this is a contrived example. That's kind of the point, is that we don't have to worry too much about the actual logic behind it. I can then show you how I use this in a more serious application. But the basic idea is that if you have a counter component, it doesn't really need a whole lot. You can say that you have a count and a set count function. You take those from state. You can use a starting prop to set the starting value. Then you create a +1 function, which calls set count, gets the current count, and returns count +1. So very simple function, pretty simple logic. when we click the button, we're going to call +1. And let's also display the current count like this. So I'm going to add a breakpoint here like that. So now when I click on this, you see the count goes up. I'm using completely local state. All of my logic is contained in the component, and it's still a functional component. I'm just saying, okay, count is now a state. Whenever I call the setCount function, it takes as its first argument it takes a function as an argument so that we can make it more dynamic, reads the current count from state and updates the state, which then triggers a re-render of the counter component. So we now have a counter component that works completely independently. We can make multiple of them and it's still going to work. We might need to add, let's turn this into a div so that they don't overlap. So we now have two counter components that have separate pieces of state. And you can render this anywhere, and it's completely independent, and it always knows what's happening. Let's say this one needs to start from 5. So when this reloads, oh, see, CodeSandbox is even nice enough to actually maintain state between reloads. So that works nice as well. So you see that hot reloading works with this approach and all of that stuff. Now let's say that each count component needs to have a separate display component. And that display component could be further down in the tree, but they're basically two components that work together. So we're gonna say this is a display, and it's gonna get count as a normal prop. We then say const display is a component that gets some count, and it returns a function that's going to render a paragraph, which is going to show that count. Now no longer need the breakpoint. Now I know this still looks kind of lame and like a stupid example, but imagine if this were 3 components deep, or if it was like this could be, I don't know, a widget on your page somewhere that has something where five components need to work closely together. We can also say that, okay, you know what, these default buttons are kind of lame. Let's make a red button component that looks better. So we create a red button component, and this one is going to get the setCount callback, and we return a button that has, we set +1. So let's put in +1, and it's on click, and let's give it a background red so that you can see it's a red button. So we now have we need to actually pass it in. It's kind of nice when editors suddenly start reminding us that we forgot stuff. So we still have a pretty simple approach where we have a button that does counting, and we have a display, and we are doing, this is basically the old prop drilling approach where we have localized state that is shared between 2 components that work very closely together. This is great for when you need to build widgets that are relatively self-contained, or widgets that are, I'm having trouble coming up with a fun example, but basically imagine if you had a header that needs to share some state between just a couple of components in the header itself. You could do that with this approach. Now, what if we want to connect both counters together so that they are counting with the same global state? So now we have components that live far apart in the state tree, and they need to work together to manage global state. We could go with Redux and do a bunch of stuff, but instead, what I prepared was a wormhole context provider. So we're now going to create a wormhole that's going to share state between 2 components that are very far apart. And these 2 components will have an indirect way of communicating without us, we're kind of hoisting state, but not too much. What did I do here? Okay, so we're going to import the wormhole context provider from wormhole context. Why doesn't it autocomplete? From /wormhole context provider. And the wormhole context provider is a React component that does a few things with its own local state to make the state shareable. And I'll show you how that works. So we take these two and we render them inside the wormhole context provider. Like that. So they're now both children of the same global provider. This is similar to your Redux provider or your MobX provider, except we're going to do a few tricks to make them easier to use. Let's see. So we have the wormhole context provider. Now we can go into our counter, and instead of using state like this, we're going to say, we're going to take state from our context, and we're going to take a little function I called setSharedCount. So setSharedCount, and we say use context, and it's going to be wormhole context, which we also need to import. So we import wormhole context from here, and I'll explain in a little bit how this works. So now we have display count, which is going to display state.sharedCount. This is where if you're using, what's it called? If you're using TypeScript, this makes it easier because it gives you autocomplete on all of these states and stuff. I didn't want to deal with that because I just felt like it was too much for this example. And now instead of set count, we're going to set shared count, and we're going to just set it to state.sharedCount, state.sharedCount. Oh, did I actually call it +1? No, it's not. Okay. So we take the new state.sharedCount +1, and now in theory, this should just magically work as long as we import use context from React. Let's see. So you see now I'm clicking one button and they're both updating. Yay, super awesome, right? And we'll go one step further and make this even easier to use. So we now have two buttons that are connected via a context provider. So the React context kind of works as a wormhole in the background to connect two components that are in theory very far apart. How the context does that is that we are creating a context called wormhole context. This would, in practice, you would probably name this differently for different sections of your application. I forget what those would be called in Redux because it's been around 2 years since I seriously used Redux last. But the idea is that you create this context, you put in some state, and you put in your actions or your functions that you use to manipulate that state. We're gonna make that even better in a little bit. So then you create a wormhole context provider functional component, which has a state. We're using just a local state, which is a state with a single variable, but that variable is an object. So we are able to have both a shared count, and we can add, let's say, random string, which says random, and I'll show you how that works later. Or actually, no, I can show you now. So if we now have random string and we want to display that over here, we can say state.randomString, and it should show up right next to us. Let's see, do I need to reload? Yeah, so we now have a random string. So we're using a single piece of state, but that state can contain an object, which then has a richer, more complex piece of state that you actually use for your application. So we have that wormhole context. We have our initial state, we have our state, then we have the context value, which is another piece of use state from React that holds our application state and any helper methods that we need. So right now we just have setSharedCount. You could then add more actions here, or I'll show you in a bit, you can use a reducer to clean up this part as well. Then to avoid having multiple re-renders whenever, so to avoid having multiple re-renders, we then use a use effect to ensure that our component only re-renders when our internal state changes. So not when the context value changes, but when the state stored inside the context value in an object changes. Then we render a wormhole context provider with our context value and all of its children, which gives us the nested stuff below. So what's happening now is that when we call set shared count, that goes into React context via the provider, goes into context value. No, let me change how I'm explaining that. So when we now render something, we take the wormhole context out of our React context and we take its state and a setter and a helper method. When we call that helper method, it's actually being passed in from our context provider, which then calls this function that we defined here. That function calls set state and updates the state, which then triggers a re-render via this effect of our entire application, of everything that depends on that state. Now, this potentially isn't as performant as something like MOBEX because it doesn't keep track of what's actually listening to which parts of state, but in practice, it usually works well enough. If you're using Redux, actually, I haven't benchmarked it, but this should be about as performant as Redux. So we have that. Now, what we can do to make this even easier to use, here you see we had all of this stuff, right? So we have a context and we have something that lets us manipulate that context, and it's kind of nice. It's nice that we have it in the counter component, but we can actually make it even better. Let's turn this into a custom component. So we're going to say const use shared counter, use shared count, which is going to be let's just call it a function use shared count, which doesn't really take anything, and it takes stuff out of context, creates a +1 function, and it's going to return our current state.shared count and the +1 function. Actually, it's easier if we do it this way, shared count and the +1 function. So we now have a custom hook. Why is this complaining? Okay, it's fine. So we have a custom hook called use shared count, which talks to our React context, creates the wormhole, creates an easier to use function that just does +1 and returns both of those as the count and as +1. So now when we go into the counter here, we can say const +1 equals use shared count. That will just work, and then display can be, let's turn that into a display count component. So we have display count, which no longer needs to take any props. Instead, what it can do is say shared count, const shared count equals use shared count. So this should now just work magically. So let's see if it does. Yep. So we now created a hook that we can use in any component, no matter where it is in our component tree, that independently connects to our global state or whatever shared state we have, and uses that state to work just locally in the same component. So now if you imagine how this works from what did I do? Here. So now if you imagine how this works from the perspective of a junior that's joining your team, or even you who hasn't been working on a part of the code base for 6 months or whatever, or you've just forgotten what you're doing or how it works, you can come to the counter component and you say, oh, okay, it's using the shared count, which is probably some context, and we're just taking out the +1 function, and we call it in the red button on click. Cool. We can even completely remove this and call this the plus button. So we change this to the plus button. We then move this over here. So we're using the shared count hook directly. We call +1, and you see it's still going to work. So what you just saw is how easy it is to refactor your components. It's easy to move using shared state to a completely different component. All of these components are relatively independent. They're no longer tightly coupled. They can always get their own state from the wormhole, and they can always use that state to do whatever they need with it, which is really nice because you can then, it makes it easier to move things around. It makes it easier to refactor. It makes it easier to say, okay, this is the plus button, just takes +1 from use shared count and does stuff with that. And we didn't have to use any libraries to achieve this. We just used a bunch of default we used a bunch of default React machinery, and it all kind of just works. You can make this even simpler. If you go here, and instead of use state, you could then use reducer. I'm not going to show you how to do that because I think it would take a little too long. So place with use reducer for more flexibility. And then in here, instead of a reducer, you would then just pass in the dispatch function from your reducer. And you then get and then you get basically the same complexity. Well, not the same complexity, but you get the same power that you have with Redux, where you can call dispatch on your reducer, which then triggers the same stuff here, the same stuff for your, for the re-renders and all of that. I kind of trailed off there, I'm sorry. But the idea is that if you like reducers, or if you have complex state that needs to work together, you can use reducer and you still get all of the same ease of use. You get the same flexibility, you get the same collocation of your logic and where you're actually using that logic. And you can still have all of the power that you need. One other thing that I wanted to mention was that with this pattern, I know that in Redux and Mobex and a couple of those others, it becomes very complicated what to do when you have asynchronous actions. With this approach, it doesn't have to be complicated because this can be an async function. So you now have an async function that just works and calls set state whenever it's ready, and React will update and re-render your stuff, and it's going to be fine. You don't need any special knowledge of how things work. It's still just functions. It's just functions working together as functions, and you can insert asynchronous stuff wherever you want. So that was what I had to show you today. I know it's kind of a pretty simple example, and I contrived a counter as much as I could to make it understandable where I'm going at with the wormhole state management pattern, but still understandable, so we're not getting into the weeds of application logic. So yeah, I hope you enjoyed the talk, and I hope that this gives you useful ideas for how to approach stuff. I'm pretty sure you can use this with Redux or in any existing React application. You can just start using it and it's going to be fine. I know it's not a library, it's just a pattern, which I prefer because it reduces dependencies and helps you. It's more about how to think about state management versus use this library and it's going to do everything for you, which I prefer. And yeah, so if there's any questions, I'm around. Otherwise, you can hit me up on Twitter later. And yeah, that's it.
I will start my video. And yeah, so let's go for it. First question, what are the best small steps and sites I can start learning React fast? I have never used it, but I use JS. And how many years have you been coding?
Oh, wow. Okay, let me just make sure that my camera works. There we go. I had to change my battery. So yeah, I've been coding for a really long time, like 22 years now. So it's been a while. And what I would suggest for learning React fast is to actually just go through the docs. The documentation is really good these days, and they did a great job of starting with small examples and going from there. You can also find there's a lot of articles and blogs about this stuff online. Yeah, I think if you look for React for beginners, there's going to be a lot of really good information out there. I don't have any that I know of from the top of my head and just build stuff. The more stuff you build, the more you're going to get used to React and how it works. And I think that now that we have hooks, it's become a lot easier to get started than it used to be.
Thank you. The second question is, what do you think about recall, Andy? I just put it into a Google, and this is the first time I have heard about it. It's state management library. What about you, SWIZEC?
I haven't had a chance to play with recoil yet, so I can't really speak much about it. It seems to be something that Facebook invented to solve their own problems primarily. And one of the things I would urge you to consider before you jump into recoil is, do I have 50,000 plus components like Facebook and 1,000 developers working on my code base? If you don't, you might not have the same problems that they were solving with recoil. If you do, then it's probably perfect for you and you should already be thinking about migrating.
Great answer. I have one question myself. So most of the time, the pattern with Redux is that between your components and the store, you put some layer like selectors, for example, just to compute the values over the state. So without need to recompute it when it's not necessary. So where would you put some kind of heavy logic, for example? So tasks which are taking a lot of time. How would you memorize it? How would you extend your solution with this?
Great question. Let me think a little bit. So I've done relatively complex stuff with this pattern and I haven't needed selectors. The main thing is that if you make your context small enough, and I see that that's a question in Q&A as well, is you can use multiple contexts. I would actually avoid having a single context for all of my application state. I would try to have contexts that are very localized, like a special context just for authentication, a special context just for your shopping cart, stuff like that. And then once you have those contexts, it becomes easier to make helper functions on top of it because they don't have to be that complicated. I would put them in the, like we made the use shared count function. That's where I would put those, I guess what you would call them are selectors. So it returns a function that you can then use to make it easier to talk to the store. And honestly, if the logic is not something that multiple components need to do, if a single component needs to do a lot of logic on top of your state, just put it in that component and calculate it every time. Like JavaScript is really fast these days. And I know that it can add up if you're processing 10,000 item arrays, but for most things in most UIs, it's actually pretty fast, I think. And even if you're using it within the React component itself, if it's slow, you have use memo. So you can memoize it automatically with the code with machinery that you already get in React. Yeah, does that answer your question?
Yeah, sure. Thank you. Some other questions appeared while you were answering. One really connected to this. Would you recommend to use more contexts or just use one global like Redux? Doesn't it get a bit messy if you have, let's say, 10 to 20 contexts in your app?
So yes, if you have multiple contexts, it can get messy in theory. The question is, what is the smallest number of components that need to share some state? And when you find that, you can create a context for those components to make it easier for them to communicate between each other, and then use global context for everything else. So you wouldn't wrap your root component in 20 different contexts. You would wrap your root component in one global context or a couple of global contexts that really need to be global. And then you would have subtrees, and you can wrap a part of a subtree in your context. So it's more like, think of it, the original title for this talk was push your state to the edge. That's kind of the idea. You're trying to find the smallest part of your edge components that need to actually share some state, and then share it only between those. because that makes it easier to understand and read your code.
Yeah, pretty much. I agree with this. That once you start refactoring your Redux store, you end up with the realization that you put it in the global state just because you could, and it was so easy. And actually, the stuff that is really global, there is a minimum of that. For us, it was some like language currency and static data, which need to be shared across that, and everything else can be used. Yeah, I pretty much agree with this. Awesome. Another question is, what would be the easiest way to find where the context provider is defined for a particular use of a shared state?
Great question. So if you're using, I don't know about other editors, if you're using VS Code, you can command click on the hook that connects you to the state. So in our example, it would be the use shared count function or hook. You command click on that. It goes to the file where that function is defined. And at the top of that file, it says import context from X. And that X is where your context is defined and where the provider is defined as well. So it's like a one step, one click, and you find it. Especially if you're using TypeScript, I think that works even better.
Roman, I hope this answers your question. If not, you can specify it even more in another one. And some more questions appearing. From Pershing. How would you go around a scenario where you need two independent parallel wormholes for the same context? Let's say you want to display two independent +1 buttons with their display components far in the DOM.
I see. So for that, so where you have a similar type of state, but it's not the same state specifically. I haven't tried that before. An approach I think would work is to create two contexts. So you could then make it a little bit more complicated and make your shared state provider accept a context function in it, or like, you know, when we call it create context and created the actual context to share stuff, you could pass that as a prop into your provider, and then you could use that. Then you could have you could potentially then have your hook that looks at the shared state also accept the context as an argument. So that would kind of work. I think that could get messy very quickly. I would question whether, yeah, it depends. It really depends on your use case, but somewhere in that line, it would be more like using context directly rather than through a separate helper hook, but you could do it. So you would basically instantiate multiple contexts and then have the same machinery attached to them. Yeah, I think that would work, but I haven't tried it.
Yep. Another question. With the wormhole context, do you recommend having one huge context per application or several smaller contexts, each per logical subdomain? I think we answered this already. Will Apollo local state management replace all other state management libraries?
That's a good question. I don't know. I don't think it will. I haven't used it. I haven't used the actual Apollo local state stuff. I've used Apollo's GraphQL stuff, which is, I think, pretty similar, and that works really nicely. I guess time will tell. It really depends.
Yep.
Let's see.
Yep. Okay. Let's see another one. Do you recommend any resources online where I can find more complex examples using this pattern with React?
Great question. Kent's blog is actually really good. I would also recommend checking out my useauth library. I can link it down here. So if you look for, if I know the URL by heart. So this is the library where well, just vanished when I clicked send. So useauth is a library where I first developed this pattern and started really using it. And it uses this pattern to manage everything about authentication in your entire app. So it's relatively complex. And it also uses the use reducer and stuff because it has so much state.
The next question, really great one. Is there any tool similar to Redux DevTools that you could use for debugging with React context? Like this is a pretty strong side of the Redux, that the tooling,
yes,
at least when you need it, is there.
Yeah, so I haven't used Redux tooling in a while, so I'm not sure what it provides these days. I know that React DevTools, they were working very hard on making hooks and context work directly with the normal React DevTools. But I honestly haven't needed it because this pattern is easy enough to use that I don't have to. I can just put a couple of console logs where I'm actually using the hooks and that works. I've honestly not had a need to try to look at DevTools to fix it. But maybe there's something I'm missing that I don't even know I could have.
Like I could probably imagine a better tooling, because in the React DevTools, you can always just click on the component and see the local state. But this can get like pretty hard with the context when they are all over the place. So yeah, but console logs for the win in the JavaScript ecosystem.
Yeah, I mean, I love console logs.
Yeah. Another question. Have you heard /used xstate? What do you think of the concept of separating logic from rendering with state machines?
So xstate, I haven't used it. It's a really good library. It's how I originally taught people to use Redux, was to think of it as a state machine and use actions as movement, or like if you draw a state machine, each action is an arrow between different states, and then your reducer does the states. While I haven't tried it, I think you can use xstate with the wormhole approach. It's just where I did the use state part inside the context provider, you could use xstate there and it would work the same. So yeah, if you have something that fits a state machine, I would definitely recommend using xstate because it solves a lot of problems for you.
So answer. And there is
JavaScript versus TypeScript.
Yeah,
it really depends on what you're doing.
It pretty much ends up or leads to a discussion whether you need types or not.
Yeah.
But in my personal opinion, I recommend them. It helped me to debug a lot. It helps with refactors. You change something and the types will tell you whether you are just breaking your application up.
It catches a lot of typo style mistakes. And actually, the best part about TypeScript, if you're using VS Code, is that you get hints on your functions. So you don't have to go look at the function definition. You can see directly in the editor what you need, which is awesome.
Exactly this. There is a question about the materials. Can you write down here the websites you name? It probably can dots.
Found the Q&A afterwards.
Yep, React.js, Weblog, and others. Please, my better so in the QA chat. Thanks. Maybe we can write up some summary also for the Slack, so people can find it there if they are there. And what was there? There was one last question. If you have a context per domain, in brackets, no global context, what value does creating hooks over the context give? For example,
so if you have, go on.
It continues. That's to use the use counter context you created, which looks like a shallow wrapper. We could use context directly. End of the question.
So that's true. You can use context directly for something this simple. If you look at my use auth library, you'll see that having a helper hook is really helpful because, like we said earlier, you can use it to make sort of selectors that combine logic on top of your state. You can make an easier API for managing your state. So what I like to do is use reducer and then put the dispatch function into my context. So I can call dispatch and dispatch actions from wherever. It's basically, it's just a way of providing a nicer API on top of the context itself, so that you have both the logic separated into its own. So you have business logic separated, shared business logic separated into its own hook, so you don't have to re-implement it every time in every component. I think that makes it nicer, but yeah, you can still use context directly and not have a separate hook at all.
Yep. And the last question, so we will not ignore it. A newbie here, where can I start applying to junior React developers positions? Is there some kind of a list of tools I need to know how to use, or maybe I just need to build a couple of pet projects?
It's a great
this
question.
Is kind of a general question. Let me help with the answer. If you just type junior React developer position into a Google and do not find anything suitable, then probably your internet is not working correctly. And where to start? Pretty much try to experiment with the libraries mentioned here, the React as a library itself. There is a lot of IDEs which are online, for example, Code Sandbox, where you can, without needing to set up anything, you can just start writing your code. And with your first tutorials and the React documentation, it's full of great links to other great people in the React ecosystem, like Dan Abramov, Ken Dodds, and many others. So feel free to start there, and you cannot make a mistake pretty much.
Yeah. And one thing I would add to that is just start applying. It's their job to say no, not yours.
Yep. And you will find out what they are interested in.
Yeah.
What the requirements are. Okay. So we answered all the questions. Thank you, Swiss. It was awesome.
Thank you.
I hope you enjoyed it as well as I did. Just a few remarks at the end. Please try to provide the feedback for us in the Slack channel. It's really important. It helps us to get better and better, and you enjoy the talks more. So all feedback welcome. Thanks for joining us. I hope that you will join us again next time. Just to mention, the next time the meta speaker will be Tim Bennings, and the talk will be a framework to lead a team to success in a challenging environment. I think that currently we have a really challenging environment, all of us. So that sounds like a really interesting topic at this time. And the main speaker and that talk will be by Chen Yu Jing, and the talk will be about CSS for internalization. So stay tuned and follow the socials for more information. Thank you all. Have a great evening. Hope you finished your beers. And yep, thank you all. Bye.
Folks.